2021, paper 1. First, you have a boat that crosses a river, arrive at the point due north of its starting point. So this is due north. So the resultant is north. It has a wind blowing from west to east, given by W. So if you form the triangle, you get this. Second question, car travels with uniform acceleration along a straight road. There is a post every 120 meters. It has a speed of 14 meters, U, passes the next post, V, average speed, 20 meters per second. So you can use the formula, average speed equals to total distance divided by total time taken. With this, you can get the time taken T is equals to total distance divided by average speed. 120 divided by 20 gives you 6 seconds. Then to find the acceleration of the car, use the formula A equals to V minus U over T. Okay, question 3. What is the complete description of a non-uniform acceleration? As we know, the definition for acceleration is the rate of change of velocity. Non-uniform means it varies with time. Question 4. A book rests on the table. The earth exerts a force on the book. What is the action-reaction pair? Which means Newton's third law. Newton's third law says that it must be equal and opposite to the earth. So which means it's the force of the book on the earth. This is the book. The weight due to the gravitational attraction force. Similarly, the earth experiences a force by the book. Next, question 5. A child slides down a slide. So, in this diagram, what we know is that friction always opposes motion. So if the kid is going downwards, friction should be in this direction. Okay. The weight always draw from the center downwards. The contact force is always perpendicular to the surface in contact. Next, question 6. A force of 18 newtons, the F, applied to an object at rest, a frictional force, small f, acts on an object. The speed increases from at rest, U, to V, 6 meters per second in 2 seconds. So they ask you what is the mass of the object. Mass question mark. So using A equals to V minus U over T, and also F net equals to MA. F net is the same, is equals to force minus frictional force. A you can sub as V minus U over T. This is the formula. Question 7. The front wheel of the car turns in a clockwise direction by the engine. The car accelerates to the right. So you can see this turns here. Friction always opposes motion. So the motion of the wheel is towards the left. So friction is to the right. Okay, so the frictional force on the wheel is to the right, but the frictional force on the road by the wheel is to the left. So you can see the wheel as the car. Question 8. A spacecraft is sent to the surface of Mars. The gravitational field strength on Mars is this, G, 3.8. The gravitational field strength on Earth is 10 Newton per kg. Mass always stays constant. So it should not change. However, the weight is dependent on gravitational field strength. Question 9. Uniform rod of weight 12 newtons is hinged at one end and is kept horizontal by a force as shown. So what's the sign of the force? This is a moments question. So in the moments question, first thing we do is to find the pivot. So the pivot is where the hinge is. The pivot. Second is the line of action. So let's identify all the line of action. Force here. Line of action. The weight of the blank here. Line of action. So you can see that this is the perpendicular distance for force F. And this is the perpendicular distance for the weight. So and finally, you solve for the principle of moments. So the force will give you a anti-clockwise moment. The 12 newtons will give you a clockwise moment. And use the formula. Moment equals to force times perpendicular distance. Next, question 10. What is center of gravity? The definition is not where the mass is the weight of the body. In fact, it's the entire weight of a body seems to act on. Question 11. Another center of gravity question. The CG is here. So how to make it more stable is by lowering the CG or increasing the base area. So in this question, you turn it upside down, your CG goes down. Question 12. A cylindrical tube of cross-sectional area A contains a liquid, the depth H, density ρ, and the gravitational field strength G. So they ask what is the pressure question mark. You know the formula, P equals to H rho G. Question 13. A force is applied to a smaller piston on a hydraulic press. So in this one, we use Pascal's principle. Okay, which states that P1 is equals to P2. Formula for P was F over A, means F1, A1 equals to F2 over A2. And you have the area, A is equals to pi r squared. So in this question, they give you radius 1, radius 2. Next. Question 14. If a fish in the ocean releases a gas of bubble, the bubble slowly rises to the surface. So how does the pressure of this gas vary with the depth? So we know the formula, P equals to H rho G. Because the bubble is experiencing a pressure due to a column of water here above it. So the depth is actually the same as your height. So with the formula H rho G, we know that the density of water and the gravitational field strength on Earth remains constant. So H is proportional to the pressure. Or pressure is proportional to the depth of the bubble. So and should go linearly. Next, question 15. There are two boxes. Box 1 is lifted vertically. Box 2 is lifted the same height along a rough incline. So which statement is correct? The work done is actually equals to mgh, which is the same as gravitational potential energy, GPE gain. You realize that the height gain is the same. Next. Question 16. A lorry is traveling at a constant speed of 90 km per hour along an expressway. So velocity, the forward force on the lorry is F. What is the work done each second by this force? Okay, so we first need to convert the velocity to SI units. 90 km per hour. So convert to meter per second. You convert it 90 times 10 to the power 3 meters over 60 times 60 seconds. And you'll get 25 meter per second. Next, we know the formula for work done is equals to force times displacement. And we also know that displacement is equals to velocity over time times velocity over time. You submit the values and you get the answer. Question 17. Smoke particles are viewed under microscope. They are moving with Brownian motion. So which rule explains Brownian motion? So Brownian motion is not a vibration. It's a random motion. And the air molecules are the one that is bombarding the smoke molecules. Question 18. The cooling unit of an aircon is placed on the top of the room. So why is this so? It's because the air is being cooled. So when air is cooled, it contracts, becomes denser due to a decrease in volume, decreases, then it sinks. For the opposite, hot air expands, less dense because its volume increases, hence it rises. Question 19. A fixed mass of gas expands at constant temperature. So constant temperature. What happens to the pressure of the gas and the average speed of the gas molecules? So remember the formula, PV equals to nRT. Since the mass is constant, R is the ideal gas constant, is a constant, temperature is constant. And when it expands means volume increases, pressure decreases. Since the temperature is constant, average speed is proportional to temperature. It means the same. Next one, question 20. A liquid changes state by boiling. Changes state. Okay. Which statement is correct? So when it changes state, the formula Q equals to mLV, vaporization. Okay, when it's changing state, temperature does not change. Okay. So it's like in this graph, if you remember, recall the graph, temperature, degrees Celsius, Q, which is the energy supplied. This is the boiling point. We realize that the liquid does not, when changing state, the temperature does not change. So this is at liquid plus gas. Question 21, not tested. Next. Question 22. Steam at 100 degrees from a kettle condenses on the mirror. What happens to the kinetic energy and the potential energy of the molecules during the process of condensation? So condensation is also a change in state. Okay, so in change in state, the IKE remains the same. The IPE decreases. Okay, remember the molecules, now they are much closer. So initially when it's a gas, they're very far apart. Now in liquid form, they're actually much closer. So IPE decreases when there's a change in state. So when does IKE decreases? IKE decreases only when temperature decreases. Next, question 23. The mass of a metal pen of 2 kg absorbs this amount of thermal energy and produce a change in temperature. So which formula we use? Q equals to MC delta theta. This is to find the specific heat capacity, small c. Big C, heat capacity, formula Q equals to capital C, the change in theta. Question 24. In order to check how well a material conducts heat, they use a flash of light directed at surface of different samples. So which block is T? So each blocks have identical dimensions and the same initial temperature. So since T should have a large heat capacity, so giving a formula Q equals to C change in theta. For large heat capacity, you require more energy supplied to raise its temperature. Question 25, Snell's law. N is equals to psi I over psi R. This is the normal. I always mention use the angles that is hugging the normal and the rays. Remember that I mentioned that light is always reversible as well. So if you get a Snell's law, use Snell's law and your refractive index N is less than 1, you reverse the angles. Question 26. A person uses a periscope to see. Now they are asking which correct position of the prism for total internal reflection, which is A here. So since light enters incident 90 degrees, there's no bending, but there's slowing down of light. When it hits this edge of the prism here, you have to undergo total internal reflection to go all the way up. Question 27. Which table about microwave is correct? Remember the acronym G, X, U, L, I, M, R. So in this, frequency reduces in this direction. And then wavelength increases in this direction. So for microwave, it has a lower frequency than visible light, and but it also can cause the heating of the body tissue. I'm sorry, this one is wrong. It should be microwave has a lower frequency than visible light, and it can heat up the body tissue because our body consists of water, just like your microwave oven. So it does have the ability to heat up body tissue. Number 28. So sometimes they use ultrasound to detect cracks in metal. In this case, ultrasound, also known as echolocation, the formula was given V equals to 2D over T. 29. what always experiences a force when placed in an electric field? A current carrying coil of wire, okay, or a piece of charged plastic. Else just a electric charge, positive and negative. Question 30. A positively charge is held close to a Earth metal sphere. Because the rod is positively charged, you will attract the electrons. Okay, so actually electrons travel from the Earth up into the sphere. Question 31. Electrostatic charging, where we use the principle of unlike charges attract, like charges repel. Okay, so this is for electrostatic charging. And then when the paper is placed over and the pattern is transferred to the paper, this is actually the last part. Next, question 32. Electric screwdriver takes 20 minutes to charge. T. The current in the battery is 300 milliampere. Okay, so take note that we must convert all to the SI units. So 20 minutes times 60 seconds, 300 milliampere, 10 to the power minus 3 ampere. Using the formula Q equals to IT. Question 33. In 3 seconds, this amount of electrons, 2.5 times 10 to the power 19 electron, passes through a resistor. The thermal energy produced at a rate of 4.0 watts. So P, the charge on the electron, is 1.6 times 10 to the power negative 19 C coulomb. What is the PD? Question mark. Okay, so you use the formula Q equals to IT to get I. I is equals to Q over T. This time the charge is 2.5 times 10 to the power of 19 electrons times the electrons charge, which is 1.6 times 10 to the power of minus 19, over the time, which is 3 seconds. Okay, then you get current, and the next formula you use is P equals to VI. You got power 4.0 watts, and the current from the previous answer, you can get the V. Question 34. The graph shows how the current in a diode varies with potential difference across it, which is the smallest and or the largest resistance. So we get the formula R equals to V over I. Okay. Also note that this diode clearly shows the current IV graph, right, is non-linear in certain parts, so it's non-ohmic at the curve region. Okay, ohmic conductors are just straight lines. So I equals to I equals to V over I. At J, point J, the current is 0, so J, current is 0, which means R equals to V over 0 divided by 0 is infinity. So J will be the largest. Okay, you can calculate for K and L. Question 35. The diagram shows a circuit containing 5 identical resistors. So in this case, what you can do, you can assume a certain current. So you assume that here it's 1 ampere. So which means this chain 1 is also 1 ampere. And since the last branch only has 1 resistor, it should have 2 ampere, twice of the current, because the resistor is half. So in total, the battery should output 4 ampere. And with this, you can calculate the ratio of L to M. Question 36. In which circuit the potential difference V is greater than 0? So in this question, similarly, you can assume the voltage. So the EMF is 6 volts for all of them. For this, it should be 4 volts. And here will be 2 volts. 4 volts, 2 volts. Because they are in parallel, this resistor is twice of this. So the PD should be twice. So using this principle, you can add all the other values in. Three volts, since they are all 10 ohms, 3 volts, because they are in series. So this entire is 6 volts. For this case, 2 volts, 4 volts, add up to 6 volts also, 4 volts, 2 volts. So you see that only D has a potential difference of greater than 0. Question 37. Heater has a switch and a fuse. Switch and fuse are always connected to the live wire. 3 bar magnets as shown. Now they ask you what are the poles. Since it's going out, this must be a north pole. Since it's going in, it must be a south pole. Since it's going out, it must be a north pole. Okay, question 39. The diagram shows a coil in between 2 poles of a magnet, and the coil carries a current. So, using Fleming's left-hand rule, north to south, magnetic field. Current is carrying in this direction. So, father, mother, child. Using Fleming's left-hand rule. The coil should go in a anti-clockwise direction. So similarly, we can do it for the other side as well. M is this direction. Current this direction. From left-hand rule, you realize that force is up. Question 40. When a magnet is moved quickly into a coil of wire, there will be a deflection. Okay, because of Lenz's law. To find the direction of the current, we use the right hand grip rule. So since the coil is going in, the magnet is going toward the right, the coil will try to resist it and cause this to be a south pole, a north pole. So using the right hand grip rule, current should be going in this direction. Okay, meaning current this direction. Current flows in this direction. So the ammetter's deflection should be towards the right.